Question 1, we're trying to find the probability that the card is a spade given that it is a 10. The probability of a spade given that it's a 10. So the way we do conditional probability is we first take the condition and we identify all of the things that match that condition. We're told we have a standard 52 card deck, which means that in that 52 card deck there are 4 cards that are 10s. So our bottom number is going to be a 4. Out of those 4 cards, we have a 10 of clubs, we have a 10 of diamonds, we have a 10 of hearts, and we have a 10 of spades. The probability of a spade from those 4 would be 1 out of 4, or 25%. So we can enter an integer. Now 0.25 is not an integer, or fraction. So obviously we will be entering 1/4. We're given the tree diagram for question 2 and the mathematical way of saying the probabilities that we're looking for. In the A part, we want the probability of, now mathematically that says M intersect S. Now if you watched the lesson video, you saw me say the intersect sign looks like an A, and if you'll think of the word and, we want M and S. So in looking at the tree diagram, which branches do we see that have an M and S? Well, that would be here. We multiply along the branches. Since that's the only branch checked, that is our answer. On the B part, we're asked for the probability of R. We will, on our tree diagram, locate all the branches that have an R. The very top branch has an R, and the third branch has an R. We'll multiply along the branches, and since there are more than one branch, we will add those numbers together. We will begin by constructing a tree diagram. So we have a box containing 2 reds and 5 white balls. So there's 7 total. In the beginning, we can draw either a red or a white. The probability of drawing a red would be 2 out of 7. The probability of drawing a white would be 5 out of 7. Since we are drawing 2 balls from the box, we will continue our tree diagram. So we can either draw a red or a white after drawing a red. We can draw either a red or a white after drawing the white. So we have 2 parts to this question. Part A wants to know what if the first ball is replaced before we draw the second one. So on our tree diagram, having just drawn a red and putting it back, we still have two reds. Having just drawn a white and putting it back, we still have 5 whites. So there's our tree diagram for part A. Now we want to know the probability that the second ball was red. So the branches that correspond to the second ball being red would be the top one and the third one. So we'll multiply along the branches and add those together. I will do this on my TI calculator. Using the TI-84, if you enter this using the fraction key, then your answer comes out as a fraction. If you had done this and gotten a decimal answer, I'll show you on the calculator, then you would have had a non-ending, non-repeating decimal, in which case you cannot enter the decimal value. And it doesn't say anything about rounding off. So the only choice we have on this one is to enter the answer as a fraction. If you look at the calculator screen, had I come out with 2 divided by 7 or 0.2857, etc., I could have done math number 1 to change that back into the fraction. Either way, you need to type an answer of 2/7. For the B part, we're going to go back to our beginning of our tree diagram. The first draw is still valid. The probability of red was 2 out of 7. The probability of white was 5 out of 7. However, if the first ball is not replaced, that means after drawing a red, we now only have 6 balls left. And since 2 of them were red, now only 1 of them is. There are still, however, 5 white ones. Same thing for the second one. Having just drawn a white, then we have 6 balls remaining. Since there were 5 whites, there will now be 4. And there are still the 2 reds. And so now we're going to answer the question, what's the probability the second ball was a red? Same question. Here's how we get a red. We go red, red, or white, red. The first one would be a 2/7 times a 1/6. The other one would be a 5/7 times a 2/6. I'll go ahead and do this without the calculator. This first one is 2 times 1, 6 times 7. The second one is 5 times 2, and 6 times 7. When we add those two fractions, we add the tops together. 10 plus 2 is 12. Now the only problem with that is it's not reduced, and I'm pretty sure that they're going to want that reduced. If we divide top and bottom by 2, we get 6 out of 21. If we divide top and bottom of that by 3, we get 2 and 7. Problem 4, we will begin with constructing our tree diagram. This time we have red, white, and green. So we have 3 choices: red, white, and green. We'll go ahead and write the probabilities. there's 4 red, 4 white, and 3 green. So that's 11 balls total. 4 out of the 11 would be the red. 4 out of 11 would be the white. And 3 out of 11 would be the green. We don't have 2 parts to this problem. We're just told that the 2 balls are drawn without replacement. You saw in the previous problem what that means. The second ball can be red, white, or green. Having just drawn a red, there are now 10 balls remaining. And 3 of them would be red. Still have 4 white, we still have 3 green. Now I'll go ahead and complete the tree diagram without you having to watch me do that. So from the tree diagram, we will attempt to answer the question. What is the probability that both balls are the same color? What branches correspond to both balls being the same color? Here's both reds, here's both whites, and here's both greens. Multiplying along this branch, we have 4 out of 11 times 3 out of 10. The middle branch, we have 4 out of 11 times 3 out of 10, and the bottom branch is 3 out of 11 times 2 out of 10. This would be a 12 over 110. This would be a 12 over 110. This would be a 6 over 110. So that would be 30 over 110. As you see, we need either an integer, that's not going to happen, or a fraction. In other words, they don't want a decimal. Since both of these top and bottom numbers end in 0, we can divide by 10 and have 3 out of 11. Last question. We will begin with our tree diagram. Now I'll go ahead and be constructing like the entire tree diagram so that you can get prepared for what's coming up next. So we start with this. An automobile manufacturer makes cars at plant A, and not all of the cars are from plant A. So here we have cars made at plant A, and there's cars made elsewhere. And we use this little mark to mean not at plant A. So this is 69%. And again, just for future purposes, that means this has to be 31 because they have to add up to 100%. We have some cars that have defective emissions. However, not all of them do. So some of them will not have defective emissions. Now technically I would have the same thing down here. However, we're not asked or even given that information. So 3% of the cars from plant A have defective emissions, which means 97% don't. Now again, we're not told anything about these, but it is not a factor in the problem. The question is, what is the probability that a car came from plant A and has a defective emissions? So that would be the branch that goes A, then D. We multiply along the branch. Since that's the only branch, that would be the answer. Typing this into the calculator, it comes out exact as 0.0207. There's nothing after the 7, so we are not rounding off. We should be able to enter that decimal value